This is Dr. Ackerman, and I'm going to talk you through a video on how to do the Pendulum Lab. It's important to know what you're doing when you walk into the lab, because simply swinging the pendulum isn't going to be enough to actually do science. The focus on this lab is going to be on making measurements. There's a few different types of measurements to make, including the length of the pendulum, the mass of your pendulum, and your starting angle. Now, if you haven't worked with a pendulum before, it's a pretty simple object made up of just a few pieces, and as you can see, its purpose is that it swings back and forth. Of course, the first thing that you're going to need to do is construct your pendulum. You also need to gather the materials that will make the pendulum. That includes a piece of string, the hanger for the masses, and a few different 100-gram masses that will go on the hanger. Finally, you need some sort of support. We use a ring stand for that. And when you tie it all together, you have your pendulum. So the first thing you need to do is decide how much mass you're going to use. Now you're going to repeat this measurement multiple times, so you might want to change the mass, adding and subtracting masses as necessary so that you have different pendulum masses each time. Now, you can trust that the mass is what you think it is, but I'd recommend that you use a scale. Make sure that it's on the gram setting, which will show a G in the top right corner, and check the mass of your hanger. It should be about 50 grams. Each individual mass should be about 100 grams, so if you have one hanger and one mass on top of it, that would be 150 grams. You can see that this is very close. After you've chosen how much mass to put on your pendulum, you need to measure its length. Again, you'll want to actually choose different lengths for different iterations of the Pendulum Lab. When you measure the length, make sure that you're measuring to about the center of your masses. So a good length for this would be about 81 centimeters. Don't pick the length, for instance, at the top of the hanger. That would be incorrect. So measure to the center of the masses. And one nice thing is that you'll be working in a team, so you can work together to make these measurements. You need to measure the starting angle when you release the pendulum. This is very hard to make a measurement of if you're working by yourself, like I am in the video, but you want to make sure that the center point is at your support and that the up-down line aligns with your string when it's hanging down. You'll use the protractor then to measure the initial angle of your pendulum. Make sure when you're holding your pendulum that you're holding it at the very bottom, not a higher place on the string, so that when you let it go, the entire thing was at the same angle. Now you can use larger angles or smaller angles, but please don't go above an angle of about 30 degrees. No angle is too small as long as you see oscillation afterwards. Now the final thing you need to do, after you know what your initial starting angle is let go of the pendulum and measure a number of oscillations. And an oscillation is an away and back motion. 1, 2, and you want to do this, say 5 oscillations, and then stop the stopwatch at 5. And then you can divide that time by 5 to get the period for 1. Now, what's something to not do? Well, don't push it hard, and make sure that your entire stand is very stable. So ideally, you want to be seeing motion only from your pivot point, and as long as your whole thing is stable and you just let it go without being from too big of an angle, you should see a good behavior. Now, that's it. That's how you're going to be making your measurements and hopefully looking for patterns of behavior. The last thing I want to talk about is how to actually do unit conversion. So in this lab, you should be writing down your values in kilograms and meters. But note that when we measured the mass earlier, we had grams, not kilograms. So how can we convert 150.4 grams into kilograms? Now there's a standard way to do unit conversion, which I'm going to talk through. If you already know how to do this, you can skip the rest of the video. But you want to have a conversion factor, which in this case is that 1,000 grams goes into 1 kilogram. Now because our measurement is in grams, you then put grams on the bottom of the fraction that represents how many kilograms and grams are equivalent. Now because you have grams on top and grams on the bottom, you get to cancel those numbers, and then what you're left with is 150.4 divided by 1,000, which will need the numeric answer to that, but your only unit left is kilograms. Now you can, of course, type that math problem into a calculator. That's something I can do in my head, so I see that it's 0.1504 kilograms. And it's okay to round that and just call it, say, 0.15 kilograms. That's absolutely fine.